Hey guys, so in this example, we're given a rational function and we need to find a whole bunch of stuff out about what the graph looks like. Okay? So you're more than welcome to use Desmos to graph this and take a look at the graph if that will be helpful, but we can actually do all of these without doing that. Okay? So I want to start, we'll just go in order actually. So horizontal asymptote is what is new this week. And notice, remember that depends on the leading coefficients of the numerator and the denominator. And here they're the same degree, right? So because they're the same degree, we take the ratio. So we take -3/5. We'd say there's a horizontal asymptote at -3/5. Okay? Now, vertical asymptote and any holes, right, take a little bit more work to find out. Okay, so we'll do those two together. Keep in mind there's two other cases for horizontal asymptotes that we just covered in the last part of this assignment, so you can always go back and rewatch that video if you get stuck on those. Okay, so for both our vertical asymptotes and our hole, so we need to factor the function for both of those, so we'll do those together. So f of x, the first thing I'm going to do is I'm going to pull out any common factors. So notice I can divide the top, each term by 3. So we'll make -3 a common factor here, so we get a positive x squared. Minus 25 then. And on the bottom, it looks like each term is divisible by 5. So we get 5 x squared plus 7x plus 10. Right? Okay. And then we'll continue to factor our polynomials here. So remember, this is a factoring pattern that we're working on memorizing here. So -25 and 0, plus 5 minus 5. And then for the bottom, that one's just 5 and 2, right? You probably don't even have to write the x for that one. So -3 times x plus 5 times x minus 5 over 5 times x plus 5 times x plus 2. Okay. And then the crucial thing here is we have a set of factors that cancels out, right? So top and bottom, x plus 5 over itself is a fancy 1. So we can rewrite this whole thing as just this guy, -3 times x minus 5 on top, and then 5 times x plus 2 on the bottom. Okay, so this is a rewritten form of f, right? So this is still f of x, just simplified. Now, our vertical asymptote now is going to be from the term that's left in the denominator. And remember, we want it to equal 0, the denominator, so we'll say x equals -2. Okay. And then our whole is related to that term that canceled out. So that's x plus 5 gives me a -5 as my x. And remember, if I want the y, I can plug it back in. So my y, this one's going to work out easily. My y would be times, oh no, it's not going to work out easily. -5 minus 5 over 5 times -5 plus 2. So I plugged in my x into my new f, right? And I get 30 over get -2 is my y. Okay, so there is my whole. And then the last two things are things you've known about since 8th grade probably, x-intercept and y-intercept. And even it gives you a hint here. So x-intercepts where y is equal to 0, y-intercept is where x is equal to 0. Okay. So we'll start with the y-intercept. That one's a little bit easier. Y-intercept, I'm just going to plug in 0. And I can use my simplified f, so it's really quick and easy, right? Negative 3 times 0 minus 5 over 5 times 0 plus 2. So we get positive 15 and 10 on the bottom. So you can just give them 15 over 10. Or that simplifies to 1.5, right? So there's our y-intercept. And then our x-intercept, the algebra is a little bit uglier here, but it's the same thing. We're going to plug in 0 for y this time. So we'll say 0 equals negative 3 times x minus 5 over 5 times x plus 2. And what I can do is I can just multiply the denominator on both sides. So the denominator times 0 is still 0. So that becomes 0 times negative 3 times x minus 5. And notice if I, 5 minus 5 is 0. So that is x that's going to make this equal to 0. And you could continue to solve it as a two-step equation if you want. But I think a lot of us are at that point where I can say, obviously 5 is my x-intercept. Okay. So again, horizontal asymptote is the new thing for the week. Vertical asymptote and the whole are our older things that we've been studying on these rational functions. And then x and y-intercept are old algebra 1 stuff. So hopefully these go smoothly for you. If not, as always, reach out if you have any questions.